Hello, welcome to the 2.3b parallel lines and transversals. So we are going to be taking what we learned in 2.3a, which was transversals, which was a transversal that intersected two other lines. And we're going to be focusing on a specific situation, one where we now have parallel lines. Okay. Now, this slide is asking a lot of different questions, like what are the corresponding angle measures, alternate interior angles, alternate exterior, same side interior. But the thing I want to focus on really is the diagram here, and we've got now have two parallel lines in a transversal, and what we're going to be focusing on is the relationship that these angles and the angle pairs that you have from this transversal and two lines that intersects, basically the relationship that these angles have and the different angle pairs that are made. Okay. First of all, we have corresponding angles. Well, corresponding angle measures, okay, if two parallel lines are intersected by a transversal, then pairs of corresponding angles are congruent. Now, the angle measure that we're shown here is the 73-degree angle, all right? But we really could look at any pair of corresponding angles, all right? We could go up here and up and to the left, we know that these angles would be congruent as well. Okay. And what's nice is if you're given one angle measure, you could actually find the other four angle measures. Like we know that vertical angles are the same, are congruent. So these would be 73. Well, we also know that the double arc and the single arc angles are a linear pair. So we know they'd add up to 180 degrees. So I think that makes all these big angles 107. Okay. So if we've got the parallel lines in a transversal, if you're given one angle, you could pretty much find all 8 angles. Okay. That's the corresponding angles. Corresponding. Alternate interior angles. Alternate interior angles with parallel lines. If two parallel lines are intersected by transversal, then pairs of alternate interior angles are congruent. Also congruent. Okay. So again, same idea. If we have one angle, 73, 73, we know we could use that information to find all of the angles. The small angles in this diagram are going to be 73 degrees. The big angle measures are going to be 107. Okay. You're going to see a little pattern here. Alternate exterior. If two parallel lines are intersected by a transversal, then pairs of alternate exterior angles are congruent. Again, corresponding, alternate interior, alternate exterior, all right, are going to be congruent. All right, they are congruent. Same idea. This is just talking about if the two parallel lines are intersected by a transversal, then we know where all the congruent angles are to the one we're given, and we know what the linear pair will be to then give us our all 8 angles. Okay, now here's the one that's different. Okay, so the first 3 we did, they're all congruent angles. Same side interior angles, all right, have a little different property. If two parallel lines are intersected by a transversal, then pairs of consecutive interior angles are supplementary. All right. And this makes sense. Let's say we kind of worked our way around this diagram. If this angle is 73, then I know its corresponding counterpart down here is 73. Well, I know that the angle above it is going to be a linear pair, which makes it 107. Well, we don't even need that information. We can just go straight to the fact that if you have same side interior angles, we know that the relationship that these two angles have is that they are supplementary. Okay? This is important, and this is something that people do get confused on, right? They get in the habit of thinking that every angle pair with parallel lines is going to be congruent, right? When that's not the case. The same side interior angles are going to be supplementary. Okay. Again, this just covers everything we just said. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior are congruent. and same side interior are supplementary. Okay. This is an example. We're not going to go through every single one of these. I did share the PDF copy of this with you, so you can look through all these and give them a try if you'd like. But we will go through a couple of them. Here's one where we're given one angle measure, and we can find angle 7, angle 2, and angle 5 from this one angle that we're given. Now you recognize the two little extra arrows here on the lines. That tells us these lines are parallel. Okay, so we know this is angle 55. So I got to figure out how to get angle 7. Well, that's that one's nice because I know that 55, this angle, and angle 7 are corresponding, and corresponding angles are congruent. So I know angle 7 is also 55 degrees. Now angle 2, this 55-degree angle and angle 2 are going to be a linear pair, which means that they are supplementary, okay, because they add up to 180. So let's see, if I do 180 minus 55, is that 125? 125 degrees. And then angle 5 is right over here. This is why I've been writing these in as I go, because it's going to help me out over here especially. I do see that this angle 55 and 5 are alternate interior angles, but the thing I looked at right away was I saw this angle and this angle are vertical angles, and I know vertical angles are always congruent. So 5, I can look at it this way too, but 5 is going to be a 55-degree angle as well. Okay. Okay, this diagram here, I do want to go through this one because we get a lot of diagrams that look like this, where you've got two sets of parallel lines. And the trick to this is understanding that the fact that you have two sets of parallel lines gives you a lot of congruent angles. And there's the nice thing is you don't have to go and work your way around the entire thing. There's only going to be two different angle measures shown throughout this diagram, and they're going to come from the initial angle you're given. All right, so we want to try and find angle 5 and angle 6. Well, I'm going to go ahead and focus on just this intersection point right here and figure out all of these angles. I know that's 63. The vertical angle part that goes with that is 63. Let's see, I think this is going to be 117 because it's a linear pair going both ways. And the vertical angle, 117. All right, I found all my answers right here. I know that every intersection point as I go around this diagram will share these angles. Every small angle will be 63. Every big angle will be 117. Now, this only works when you've got two sets of parallel lines. Okay. Now, in doing this, we found our two angle measures that we were looking for. And 5 is 117 and 6 is 117. Okay. All right, I am not going to do this one, and I'm also going to skip over this one. But we're going to get into proving lines parallel. And the way that we can prove lines parallel is by finding a value that will make the statement true, or by making the theorem true. Okay. If we have congruent corresponding angles, congruent alternate interior angles, congruent alternate exterior angles, or supplementary same side interior angles, then we know we'd have parallel lines. Okay, so it's basically going backwards from what we did to start. We were given the fact that we had parallel lines to start, and because they were parallel, we knew the angles were congruent, and supplementary. Going the other direction, if we can show that angles are congruent, then it proves the lines are parallel. Okay, so it's kind of going the other direction. All right. Now, the way we're going to do this a lot of times by proving angles are is by solving for a value of x that makes it true. So we're going to solve for x here. We got to solve for x. Now, in this case, it's not asking for an angle measure. It's just asking for x. So let's go ahead and set that up. We have to identify the type of angle pair we have. Now, here's our intersections. Looks like this is interior, that's exterior. I think we have a pair of corresponding angles, which corresponding angles will be congruent. So we can set up our equation, 3x minus 33 equals 2x plus 26. Subtract 2x from both sides, add 33 to both sides. I think x equals 59. If I wanted to find the angle measure, I could plug that in. 3 times 59 minus 33 and get our angle measure, or 2 times 59 plus 26. All right, here's one where we've got the two angles we've got here are this angle and this one. Let's identify the angle pair. Here's our transversal. They're both inside interior, but they're on different sides. These are alternate interior angles. They are congruent. Let's set up an equation. 2x minus 5 equals 95. Add 5 to both sides. Divide by 2. All right, x equals 50. I'm not going to do this one. This is another one where we have a pair of corresponding angles. They will be congruent. Okay, this one I do want to do. Solve for x if AB is parallel. We've got two angles. They're both interior, but they're on the same side of the transformation or the transversal. Excuse me. These are same side interior angles, which makes them not congruent but supplementary. So let's use that rule to talk about it. It's going to be 2x plus 9 plus 111 equals 180. Okay, this isn't one where you can set them equal to each other. We've got to add them together and set them equal to 180. I'm going to do a little work here. Let's see. We got 2x. I'm going to combine 9 and 111 to make that 120. Subtract 120 from both sides. Divide by 2. We get x equals 30. This is one where we got to do a little work. I'm not going to do the entire problem here, but I am going to talk about how to set it up. You can do this a couple different ways. We could, because this is not a specific angle pair here. All right, 130. That's an exterior angle. This is interior. But the only pair we know that are like that are corresponding, and these are not corresponding. But I do know that this 130 degrees is a vertical angle with this. So I could now use same side interior angles. Or I know that this 130 corresponds to this angle, which I can use the linear pair of these two angles and know that they are also supplementary to do 2x plus 10 plus 130 equals 180. So you can set this up and solve for it, but you got to do a little work ahead of time to get there.